太慢了。
आज हम लोग टीजेड सावेल से संबंधित इलेक्ट्रिकल आइटम्स के बारे में ट्रेनिंग देने के लिए एकत्रित हुए हैं। तो आप लोग सभी परियोजना से हैं, तो आज हमारे साथ में टीजेड सावेल के सब पूरी टीम उपस्थित है। आप लोगों को इसके बारे में आज अच्छी जानकारी दी जाएगी। आप लोग कृपया ध्यान से सुने। ये प्रोग्राम दो दिन का है, आज और कल दोनों दिन आप लोग को आना है। और कोई भी क्वेरी होगा तो सर लोग हैं, इन लोग से आप लोग कंसल्ट करिए। साहिल कुमार इसी CTI में थे, आजकल एक्सक्यूशन डिपार्टमेंट में हैं, तो वो भी आप लोग के साथ रहेंगे पूरे टाइम। आप लोगों को कोई भी प्रॉब्लम होगा बताइए हमको आकर, ठीक है। तो आज हम लोग कार्यक्रम का शुरुआत कर रहे हैं, ठीक। ओके, अच्छा हम कुछ चीज आप लोग स्टार्ट करेंगे तो
थैंक यू सर। जैसा सर बोले हैं कि आज ओरिजिनल प्रोग्राम जो है टोटल होल डे का सीमेंस के द्वारा दिया जाएगा टोटल क्लास, और सीमेंस के रिप्रेजेंटेटिव भी लाइन में आ गए। हम लोग जस्ट अब स्टार्ट करेंगे।
看到我在上传东西吗？看不到是吗？
So Madam Jeep Manglan, electrical expert, Mr. Frank Don is expert.
我先把这取消吧。
Electrical expert and Mr. Ho को तो सब जानते ही हैं।
共享那里头。
तो ये लोग सब आज जो है सो टोटल सीमेंस का है। बीच में कहीं भी कोई ऐसा डिस्कशंस होते हैं उसमें मैडम भी हैं, AB हैं, जो भी हैं, मिस्टर वो हैं, वो बीच में इंटरवीन करके जो भी डिस्कशंस होगा वो सब इसमें पार्टिसिपेट करेंगे। वैसे जनरल इन लोगों का जानते ही हैं, चाइनीज है, फिर इंग्लिश में कन्वर्ट होगा, और फिर अगर कहीं पर कोई डाउट आता है किसी को भी तो हम लोग कोशिश करेंगे कि हिंदी में भी उसको कोशिश करेंगे। आप लोगों का सब है, हम लोग मिल करके अच्छे से अच्छा
能看到。
Okay.
Now you can start.
Okay.
我刚才上传的文件在哪？哎呀，找不见了。
那就
开始吧。
招募，你看谁先开始，咱们可以开始培训了。
现在桌面能看到吧？
现在可以开始了啊。
先能看见他的电脑屏幕了。
在哪里头啊？刚才我看的呢。
把课件打开。 现在把课件打开。等我。
这是屏幕共享。
对，现在就是可以做屏幕共享啊，直接您就按照那个屏幕就自己的 PPT 可以讲。
刚才已经打开了课件。
这个刚才弄的是虚拟机的，哎呀，真是。我转一个那什么 PP 那什么吧。这怎么又？
你先别下去了，咱俩先在这儿吧。有可能需要翻译的，还有。
ठीक है।
咋了？
他这个翻译你看 PPT 文件打开，刚才已经打开了，
刚才不打开了已经。PPT 打不开，转成 PDF 打开就也行嘛。
哦，
转成 PDF。
稍等一下。
要不就我看那个原理图都打开，先讲原理图呗。你先开。
别，先那个一下就转了。你看，它的 PDF 没问题，先转成 PDF 这就行了。
对，可以了。 带着本子屏没干。
能看到屏幕吗？
能放大吗？
放大是吧？
对，现在是比较小。
比较小。
比较小呀，这在哪里放大呢？
就弄成全屏。
啊，这行。
这可以吗？
这个可以。
超出范围了。
那还行吧。
超出范围。
能那个。
这个影
可以吗？
他那影子。可以可以。
好了，
可以了。
能再大点吗？能再大点？可以再大。再大。哎，可以了，可以了。
太大，超出界限了。
啊？
超出界限了。
没有啊。
好，超了西门子那个。
能放大吗？屏幕。点右上角。
点右上角第二个。
右边，你往右，再往右，再往右，再往右，往下一点，往下一点，往下一点，往右，再往右。
全屏，点那个全屏那个。
那个
箭头。
你稍等啊，我的里面是在虚拟机里头，我看一下。哎，是这个吗？哎，既然这个地方怎么能把这个信息框给它去掉？
小齿轮的左边。
这个。怎么能把这个东西去掉？在虚拟机这个地方。我知道他现在让我什么修正屏幕，哎呀，我去，我这看不到这些菜单这个地方。
开始吧。
把这个关掉是吗？
स्क्रीन के लिए कोई शॉर्टकट क्या होता है? नहीं शॉर्टकट F11 होता है ना F11
现在选择哪个？你们
他看不见，都为他发视频。
You tell the shortcut is F11 这是吧？Yes那
我给他发视频了。
You can also press F11 看群里我给你们截个图。
我给他发视频一下，发视频直接看一下。哎，张工，
你点这个吧，你看点这个，
你是不是那个小齿轮旁边那个最大化的那个按钮？
这个。
哎，对，好啊，
这个。
哎，对。
行了，好，
可以了啊，这就好了嘛。
好。
一开始就这样的，我记得。OK， 可以了，开始吧。
OK， 那 let's start. Hello everyone, good morning. Many thanks for joining this meeting. The first one I have just have a self-introduction. My name is Liu Fei from Siemens Drive Product Support Team. Okay. Today we just have some training on S120 of the Taichung shovels. Okay. The first we just have some contents for you. The first introduction on drive system just include something overview of in-feed technical data, hardware interface connections, and some basic principle of control. The next part, we just give you some introduction on the fault mode of CT. Yeah, maybe something happened, something fault on the CT actually happened on our side. So we just give you some information on this one. The third part, we just give you some information of some sort happened in the field. At the same time, some recommended measures will be introduced. And this is the third part, just a basic principle on some faults, just have a overlap with the third part on our training course. Okay, so we just give you some overview. The detailed information, we just in the part 3, just to give you something. Okay. So we just like start the first part. Introduction. This is just to give you over temperature. The drivetrain of Taichung's, the shovels. You can see the whole constructions, the drive system include lubrication cabinet, motor hoist, compressor, cable line, and high voltage cabinet, main transformer, auxiliary transformer, auxiliary cabinet. This is electric room and the PLC converter auxiliary cabinet. Okay. This is the motor rotation and pushing. Okay. Just to give you the overview pictures. The next one, we just give you some the drivetrain configuration of Taizong the shovels. Okay, this is the converter arrangement, cabinet arrangement of drive system. Okay, the first we just have input voltage from the power grid, and this is the rectifier used with the ALM, and side just we arrange the left side hoisters, the left side, the right side we just have the pushing drive or something else. This is the control cabinet. Okay, this is all the features just to give you how the arrangement of the old drives. Then I just give you some information on the basic type of FIT in Sinamics converter. You can see there are 3 types. Okay, we which almost they have are adopted 6 paths totally for rectifying. The first one is the basic line model, just like this one. You can see only rectifying, not feedback power from DC link to the grid with the diode or resistor as power unit. This one, okay? The next one is just named smart line model, rectifying and regenerating. The power can be double directions communication between the grid and the DC link. And the power unit is used the IGBT and feedback diagram. And the third one is just used in the Taichung's shovels control unit, drive unit. Okay, it's named active line model. This one is just rectifying and regenerating. The power can also be double directions communication between the grid and the DC link. The power unit with the IGBT and the feedback diagram. So we just give you next slide, next part, we will give you detail about this one, the ALM. Okay, this is just to give you the data sheet. Data sheet just show line the voltage and the power range, the voltage range. Okay. This is the whole picture, just to show you the directed view. What is it? What look like? Okay. So normally we just give you some information about ALM. The schematic of ALM and AM. Okay. And this part is just a grid with constant voltage and frequency. This is from the power supplies. Okay. The second part is ARM and ARM. In ARM, this part, there is a pre-charging register and a clean power filter. And in ARM, this part, with the 6-pulse topology to transform the 3-phase AC voltage to DC voltage. Okay. But the dislink voltage is a little higher than 1.U line. Okay, 1.4U line, a little bit higher. So we just give you some information about how to control the ARM to run or stop the sequence control. The first step is ready for switch on from the ARM. And when we just get the ready signals, the PLC or some operator to just release the on command to the ARM. Then the next step, the pre-charging the connector switch on, this one. And the AC power to charging through the pre-charging register and the diagram to charge the DC capacitors. And according to the capacitor of this link, charging the time will be last to 1 to 2 seconds. And when the DC voltage is getting 80% of the rated voltage, then the charging completed. The bypass conductor, this one, will be switched on, and pre-charging the conductor will be switched off. Then the IGBT, the pulse, will be enabled. Everything is okay. So the ARM will run. If you stop the ARM the sequence will be the reversed. The first IGBT pulse will be the disabled. Then we just switch off the bypass connector, switch off. Everything is okay. Just stop the ARM. This is the control sequence. Okay. From this picture, we just give you some main factors on the ARM. The first one is just control the rectifying regenerating unit in IGBT technology for sine line current. The second, the power factor control. Yeah, normally factory default settings cosine phi equal 1. The third part rectify function as voltage boost operation. So you just see always DC link voltage always higher than the U line. Okay, U line just from the power grid. The fourth, the clean power, this one just for negligible to eliminate line harmonics. You use this one. Okay. This picture just give you some introduction of interface and connection on AM and ARM. Okay, so we just give you the again function of AM. The first one, pre-charging the DC link. Just so you can see, this is the hardware. The pre-charging the register and pre-charging the connector. Okay, and the second is the input voltage of ARM check using this one. Okay, his name the VSM, and using these signals to check the phase sequence, phase angle, altitude of the voltage to control the VDC DC-link voltage and the power factor. There is a is very heavy or very large reactor in here. Using this input reactor for both the Barker circuit to realize the DC-link voltage. Okay, just as we see in last picture, normally VDC-link voltage is a little higher, input voltage. Normally it's 1.5 times. And there is a clean power integrated to filter the high order harmonics produced by ARM with the PWM modulated. And also there is some C3 filter integrated for TN neutral grounded. It just focus on the EMC issues. Okay. Also, in the ARM there is some interface, such as control power unit and auxiliary power unit for cooling fan, and all this combined together to realize the ARM the function. Just we talked. The function ARM. The first one is modulated pulse for IGBT to realize the VDC control and the power factor control, which generated CIM and IPD. This is the CPU to realize the control algorithm. The second one is at the same time CIM management all the components, including the command to ARM to control pre-charging. This one you can see. Okay, there is some IO send the command to the ARM to control the pre-charging contactors and the bypass contactors. Okay, and at the same time, the CIM realized the information exchange with the CU drive link by drive link communication. Drive link communication, which is the internal high-speed communication protocol in Siemens. Okay, this is a picture just to give you the whole, the hardware on ARM and AIM. And this one just to give you detailed connection of ARM and ARM. This is the internal ARM and internal pictures of ARM and ARM. You can see this is a ARM. This is a pre-charging the resistor, pre-charging conductor, and this is the voltage sensing model VSM to checking input voltage to check the phase sequence, phase angle, and altitude. And this is this one is just C3 for EMC, and this one is just a clean power filter, just for the filtering the high order harmonics produced by the ARM. This is the reactor for the boost and buck circuit. Okay. There is some auxiliary circuit, cooling fan, and some control unit. Okay. And this one is just the ARM internal. And the main circuit include there is 6 pulse rectifier using the IGBT and the diagrams. Okay. And there are some, the most important is control unit CIM and IPD electric nameplates in it. And there are some okay, there are some exchanging information between the CU and the CIM with the drive cooling interface. Okay. This picture just give you the different free size. In the small free size, the bypass connector just integrated in the AIM, and the large one, the bypass connector is outside the AIM. Just a different working sequence and working principle is the same. And this picture, this slide, I will just give you a detailed working principle of ARM. The first, rectifying working mode. In one word, in rectifying operation, the ARM operated basically like a motor module in regenerated operation. The line supplies takes the position of the motor. In rectifying operating, current flow from the freewheeling diagrams dominate. You can see. Okay. So we just give you the simplified principle for the operation. Phase 1, 2 line phase are short circuit. This one and this one, IGBT just switch on at the same time. And in this phase, the short circuit current is limited by the stand-up reactors, and the magnetic field of reactor acts as energy buffer. Okay. Then the phase 4, the short circuit is interrupted by this one, the IGBT, the switch off. This IGBT switch off will result in the last current gradient because of the reactors. So the self-induction voltage is added to the current valid line voltage. That results in voltage exceed DC link voltage. It's a little higher than the DC link voltage. So we can charging the current from a power supply to the DC link. This producing is cycled based on the pulse frequency of the pulse frequency. Okay.
Okay.
So this is the rectifying. And another working mode is generating. Generating means ARM operated basically like the motor module in generator in the motoring mode. And in generating operation, the current flow through the IGBT dominates. You can see. We just give you some simplified principle of the operation. The phase 1, at any moment, the DC link voltage is always higher than the line voltage. And then we just switching on 2 IGBTs. You can see this one IGBT and this one IGBT. We just connected positive and negative DC link bus to connected the matching line phase. That is why we using the VSM to check input voltage. Okay. Then the phase 3, the energy is feedback to the line because the voltage of this link voltage is higher than the power supplied voltage. So the current is just from from this link to the power grid. And phase 3, to control regeneration, one IGBT is switch off. Just for example, just this one. Then the step up reactor, very large reactor, maintaining current flow through the matched free wheeling diagrams. And this process just the cycle. The cycle working cycle period just based on the frequency, pulse frequency. And this slide will just give you some control principle on AM and ARM. How to realize the control, the VDC voltage and the power factor. This is the physical model. You can see. This one is just there is a 2 voltage short. The first one is the U line, power from power grid. The second one is U ARM, input voltage. There is a set up a reactor, very large reactors between the 2 voltage sources. You can see. And the voltage vector of reactor, you know, the current through this reactor always orthogonal to the current to the voltage. Okay, this one and this one always this vertical. And this one just to give you the vector diagrams. You can see that the phase angle relationship. Obviously, the U line from the power grid is fixed. This one, but voltage vectors of ARM can be modulated by the PWM. This one, we can using the PWM to control the altitude and the phase angle respected to the V line. And then we can control the current, circuit current, relative to the vector of U line. Then we can realize the power control. You can see this is time doming the curves. This is U line, the fix. You can control the U ARM forward and backward, and we can control the line current. Okay, forward and backward. If we just need the power factor settings equal 1, we just making corrected pulse modulate to control the ULM. Then we can get the same phase, same angles between the U line and I line. Then we can get the power factors equal 1. This is just the control principle for your reference. Okay. Let's talk about for the clean power filter. So you can see the clean power filter just in between the power grid and ARM. This is the ARM input voltage. There is a lot of high order harmonics. By this filter, we can get the perfect sine waves. How did you do that? This is the topology. Okay, this is the topology. Just L, C, L topology. Clean power filter as passive filter with the resonance, and is designed to filter the high order harmonics, not to exceed the tolerant limits. It's up to 50 harmonics, and the low frequency, the most can get the high frequency is the 9 kilohertz in rated operation. On the line connection point, you can see the values of this turbulent voltage is read very small percent of harmonics, not oversee to 1%. This one, okay. This is the harmonics, the toplet, the picture, just to show you. We're just finishing the introduction of the ARM, and then I will give you some information on multimodule. The first thing is that hardware of multimodule almost the same with ARM, such as domain secured topology, CAM, and interface, etc. Almost the same, but there is some difference between the ARM and the multimodule on the pulse modulation and control principle. So I just give you some introduction on the principle for multimodule. And this slide will give you the function of multimodule. Multimodule just change transformer the DC voltage to 3 voltage. 3 voltage, variable voltage, variable frequency. Okay. And this voltage, how to transform this voltage to the 3 AC voltage using the space vectors. And multimodule can back the power double directions from the motor between the motor and the multimodule. This slide just to give you the information on the vector control. Just for example, based on the asynchronous motor. This one is just the vector control. This is the game unit. We just call it the PWM modulator. This is the hardware of the multimodule. Okay. And we just give some introduction on the field oriented control. Field oriented control is very complex method of controlling the 3-phase motor. By the field oriented control, the equations which disrupt motor are not referred to the fixed coordinate system of theta, alpha and beta coordinate, but instead to rotation magnitude field of the rotor dq. In this rotation coordinate system, which is rotor field oriented, the state current can be split into 2 components. One is a field producing component ID, and the second torque producing the component IQ. The field producing current component ID is responsible for the magnetic field in the motor, and the torque producing the current component IQ is responsible for the motor torque. thanks to the independent and directed control of the field producing the current component ID and the torque producing current component IQ, a high degree of accuracy and, more importantly, an excellent dynamic response are achieved with this control method. The three measured actual motor current values I, L1, L2, L3 are converted into the two current component ID actor and IQ actor of the rotating DQ coupling system by means of the motor model, which includes the coordinate transformation, this one. And the values of the ID actor and IQ actor are constant in the case of the symmetrical three-phase system in the motor with pure sine motor currents, which are auto-phased by 120 degrees in each phase. So, and then they are compared to their set point, ID and IQ, and applied to the different dependent current controller, ID current controller and IQ current controller, we can get the controller output 2 voltage components, VD side and VQ side. By the rotating in the rotating DQ coupling system, then we're using the coordinate transformation converts the 2 voltage components into the fixed alpha beta coordinate system. The angle rho, this one, between the rotating DQ coordinate system and the fixed alpha beta coordinate system, which are required to convert coordinate, is calculated by the motor module. Using these two voltage components, V alpha and V beta, the gating unit generating pulse meter to control the IGBT in the three phase of the power unit of the converter. This is just to give you some explanation of the principle of the vector control. This picture just to show you the space vector, game unit space vector, for your understanding the working principle of the motor module. This is the topology of the motor module, this one. And there is 8 switching gate in the inverter motor module. The effect of these states in the motor can be defined by voltage phases. You can see Z1, Z2, Z3, and Z6. Another way, just Z0. Z0 means 1, 2, 3 on, or 4, 5, 6 on, just Z0. So there is 8 voltage states. Voltage and frequency must be specified in vector control for a current operating state of motor, characteristic by the speed and torque control. Ideally, this corresponding to the control for voltage vector on a circle path. You can see this is the sine waves we can get any moments we can get a phase voltage vector, just like this one. You can see this one, the blue one corresponds with this, the green one, the red one. On
没完了。把这调了，调什么？
先等上一下。
周工，您那儿能听到声音吗？
能听到。
啊，可以的。
张工，咱们继续吧。张工，
柳工，稍等，我联系一下柳工。
哎，好嘞，好嘞。
哎。
不在。
于工，啊，于工，啊，柳工的声音现在听不到啊。
张工，现在看不到那个，看不到共享文件了。
哦，好的，稍等一下，我正在让柳工处理啊。
哎，张工，要不你这边先处理着，我让这边的人先休息到10分钟。
啊，可以的啊。
好嘞，好嘞。
于工，那个共享文件那个看不到了，那个现场呢先休息10分钟，咱们这块呢正好再处理一下啊。好的，好，谢谢啊，嗯。
Okay, 10 minutes break. We'll continue after.
10分钟，接着啊。
对。Stiamo provando bene. Se stai in gioco. Yeah, sit in the I have it.不是，你当然而已，就是没什么吃嘛，我看早，我们这样太多了。要然后这边更麻烦，他是写的久，这个
当这个长时间
烧了一下，这我们自己200。
那个你想想，他这个情况下，真怕这个东西，反正一起下。
这就到了。
啊，我记得这个吧，那个，再看，他们。
哦，对。
剪了之后买。是我可以一起买。
对吧？错过了，对，对呀，因为我这只能选这两个，这个差不多，这个稍微最后点，对吧？一共上了这么多，但是这个。就是说，哦，应该是因为你动，就是咱们这个，啊，
张工能听到我声音吗？
能听到刘总。
好嘞。
现在休息的。啊，现在咱们刚才说休息十来分钟，稍等一下客户那个就座以后，咱们再开始。
好。
现在大点，你比如说现在客户用了这个 APP， 就是 APP 要提 APP 的，这样下到因为前期我想到项目，但是前期肯定它还没有到一致程度的。这前期的话，我们现在去的话是，对对，它是需要重新发展的。不管这个，就说这个，现在我指的一个，我们现在要换成一个前期第一个是现在给抓软件大概从哪下？是不是这方面？